This is Mark at SkyTour LiveStream. I am here with Daryl Mason. Hey, Daryl, what's happening?
Hi, Mark. Enjoying the weather.
I
Haha.
I would yeah, okay. Yeah, we had some fun weather yesterday. This picture you see on the screen, this is our dome, and it is intact. We went through a hurricane yesterday, and I watched the wind whip around that thing like it didn't know the front from the back, because on a dome there is no front or back. You know, if you put someone in there and tell them to go stand in a corner, their head will explode. So yeah, we didn't have any damage to the dome. I of course battened it down like you cannot believe. I spent a lot of time getting this completely, well, I should say weatherproofed. You know, and when I did that, we ended up finding that the whole screen. I'm sorry, not the screen, but the dome. This whole part here, I had to when the shutter came down, I had to seal it and hold it down from the inside. Not myself, but I had to actually make it bungee corded to the floor. So I bungee corded to the floor. Telescope, all the appendages were taken off. The telescope was put in a parked position, safe position. It was covered in plastic and wrapped up tight to the pier, and then it was covered with a tarp, wrapped up tight to the pier. And then I ended up putting another tarp inside the computer bay and covered all the computers up in there so that it wouldn't have any trouble. And luckily, it weathered, and the inside was soaked. I mean, the wind coming through with the rain was horizontal sheets of rain. The winds approached 70 miles an hour, maybe a little more, and the winds came from such a direction such that the wind could crawl up underneath the edges of the dome, okay, which are actually down here, okay. The wind crawled up under here and filled this thing with just a mist, but none of it got on the telescope. Nothing got on the scope at all, as a matter of fact.
Good.
So we survived. We got through it, and Hurricane Isaias, or however you pronounce it, uh, Isaias or however, did not touch us. So that's good, considering that the telescope in there is the one slated to go to Arizona. And so tonight, it was perfectly clear all day long, and then tonight, just as I was getting ready to stream, we saw clouds. But not to worry. I think that we have a chance of getting through this. Hello, folks. I'm right here, and Daryl's here too, as we said, and we are gonna do an interesting, uh, well, some interesting stuff tonight. We're actually gonna look at the clusters down in the Milky Way area. And where's that? Well, if we look at our planetarium, we are. I'll pull out for you. We are looking toward the south. This landscape that you see, and I'll actually increase the size for now, just so you can see what's going on. The south. That's actually my real southern horizon. Okay, and I made a photo of it. All right, and we see the moon is just coming up now, but the moon is just uh, so close to being just past full that it's not worth trying to look at any nebulas. So we're not going to. We might, just because they're there. But this is the dome, and you see it goes on an angle. That's because the telescope is mounted polar. That means it's aligned with these lines. Actually, uh, these lines. Okay, so that when we go to the side, okay, we still have this vertical. See how that is? This is like the Earth being suspended over us. If you could take the latitude lines and longitude lines and stick them out from the Earth and extend them out, this is what we see. Okay, so when we look at this beautiful vision that we see here, the telescope's following those lines east to west. So there's the east side, and it'll rotate through to the west. So the telescope only has to manage this direction and fight the rotation of the Earth, which is going that way. The Earth's rotating that way, but the telescope is following the stars as they go that way. And if we were to zoom in and zoom in, all right, and zoom in, all right, and we put the other lines up, Okay, let me get rid of these guys for now and bring these up. You'll notice these are the lines of our local horizon. So these are the lines, for instance, that are just like permanent over our head. Okay, they're altitude and azimuth lines. And azimuth is this direction, altitude is how high above the horizon it is. They are not, it's local to you, so the stars will move around it. So when we zoom in and zoom in, you'll see that the stars are actually moving against those lines. But the reason that we're seeing the stars staying here is because we're following the stars with the telescope, right? And these azimuth lines are going to be changing every moment as the stars begin to move in their onward trek toward the western horizon, where they will then set. So we have, oh, look at that, Daryl. What's that? Okay. So they basically will be looking, they will be, in their positions. And we're going to be using these lines here, these altitude, how high above the horizon it is, okay, and the azimuth lines, the angle away from north that it is, to determine where we're going. And the telescope knows where it's going. Now, for those who have not been here before, and I know that sounded a little confusing, but it'll get clearer as the night goes on, I promise. I'm going to show you a little bit about how it works around here. Okay, so what we see, and up here, okay, what you see over your head right here, over my head right here, this is the telescope control cluster. This is controlling the telescope here if I want to move it manually. So if I want to move a little bit to the west, I can move a little bit to the west. If I want to move a little to the right, I can move a little bit to the right. Okay, and I can also go up and down. Then down below here, this is the computer telescope. This lets me get into, modify some of the things that I know how to get to in the menus. This down here is focus. So we can actually go into a focus mode, for instance, and we'll see a star right there. And we can use these keys over here to focus a star. I've already done so. You'll see it's a little bouncy, which means it's a bit unsteady sky tonight. That's one particular star we were looking at. And then this guy, actually right there. And then down here is a filter wheel. Now, the filter wheel allows us to look at the different aspects of an object using different types of light that we're getting from the object. Right now, we're not using a filter right now. It says it's on filter wheel 5 right there, and it's a wheel of 5 filters, okay? So these 5 filters will roll around and rotate around as I click on them. So when I go to 1, watch how the screen changes. It's a narrow band filter that's coming up. So now we only see a very little bit, apparently, of stuff. But this is the thing that we use for some very, very long exposures of nebulae so that we can actually get specific wavelengths. So it's very narrow bands in very specific locations in the spectrum, which are very important to us. Hydrogen alpha, sulfur, oxygen 3. Okay, these are very important locations because those give us all the colors and the things that we see in a nebula. Now, if we go with a slightly wider swath through the nebula, through the spectrum, then we get what I call a wider narrowband filter. That's what this is. So we see more of the star visually in the screen, and we're actually taking a little bit more light around each particular slot in the spectrum that we're picking from. And it gives us a more broad view, right? Number 3 is really interesting because this shows us the spectrum of the star. And we can actually observe the spectra. We can actually look at what's in the spectrum of the star and then determine what is actually in the star itself, what the star is composed of. And whereas right now we can't really see too much in here, we can use a special tool I have, which will allow us to examine everything that's going on inside the star. I can actually also bring this down to show you the brighter spectrum. And, it's a little bit, because we did this as a digital enlargement, it looks a little bit rough. It doesn't look like it's quite focused, but in fact, it is better focused than you realize. And that's just a way for us to look at the spectra of the stars. We don't necessarily have to. We don't necessarily do it. But I do have a spectrometer, which I have here, and the spectrometer is a professional grade spectrometer. And this telescope is going to have what you see on it for Arizona. But then in the Connecticut Dome, I'm putting in another telescope, which you can't see, but it's behind me on the table. And it's going to have the professional grade spectrometer on it, as well as filters to show us the sky like we're used to seeing it. All right. So I think you'll be very happy with that. And then filter wheel 4, you see nothing. Well, that's because filter wheel 4 is a dark screen, and it doesn't allow any light to get into the telescope's camera. And that's because we have to shoot something called a dark frame from time to time. Now, this is filter wheel 5, and you'll notice that the stars seem to have gone away, and that's probably because of clouds. To confirm that, we can actually go in with, this is our camera control section over here, and we will increase the sensitivity, and you can see that we actually have some clouds down here. You would see stars very brightly right here if there were stars. Now what we could do is see if we can move up out of those. So there's a star peeking out from through the clouds. See that? And then you'll notice as we climb northward here. Oh, that's more like it. Look at that. Look at the change. Isn't that incredible? Look at that. I mean, I consider that that's sort of pretty in its own way. Don't you think, Daryl?
Oh, that's cool.
It is kind of cool, but it's too bad that it's doing that, right?
Yeah.
Yeah.
Luck of the draw. Roll the dice.
Roll the dice. That's right. That's right. Roll the bones. So, what we'll do is, now, as far as where we are in the sky, we can always consult our planetarium view and see where we are. And the reason we know where we are is because we have a telescope view right here. See? Scope. And that tells us where we are. And if we come up to here, this is the Sagittarius star cloud. Now, we have this is a very, it's a highly magnified view of the sky. So we're not going to see beautiful star clouds from the wide angles like you see. We're going to see lots and lots of individual stars, okay? So let's go to the star cloud location right here for a moment, all right? And you'll see the stars move out of the way. Zoom, they go away. And it's delayed, but you'll hear the telescope as well as it shoots its way over to it. Yeah, let's see. Okay, I think maybe... Oh, okay. Okay. Okay, so here we are. So now we've moved over to this particular location in the sky, and this location is right here. Let me just...
So many stars you can't find your scope.
I know. Well, we're actually getting to that now. There we go. See, the telescope's now moving into this location, and we should see it. And look at that. You can actually see this plethora, I love that word, of stars. And when we come in here, and you come in here and look, okay, you'll see this one star right there. All right, and over here, you figure, well, maybe it's probably that star right there, and it may very well be. But now, we also have a guide system on the scope that's automatically doing this guiding. So when we look at this, what this will do for us is it's going to give us, I'll just go into this to show you what I'm talking about, to see more stars. It's going to find a guide star, and while we're waiting for it to find a guide star, I'll just show you some of the live views of the Milky Way. Look at that. I mean, look at all these stars. It's just a phenomenal view. Little tiny things like this. This is a live view, by the way, so if something goes through, you'll see it. This is a live view. So this is a absolutely beautiful view, focused, magnified view of the Sagittarius star cloud. So let's get rid of this for now. We're gonna drop off this 4K preview. We're gonna drop down to say 8,000, and look for satellites too. You might see satellites wandering through the field, especially down here. You might see some really cool things. All right, and we're gonna take just a 10-second photo, okay, of this location at 8,000 ISO. This is what's beautiful about, surveying the galaxy and looking for cool things. Just watch how these things show up and what you actually see. It is just beautiful. Okay, look at that. This is just an amazing view. And there are those 3 stars I talked about before, right down here. Okay, look at the colors.
A surfeit of stars.
Yes, exactly. That's right. But we got some beautiful stars here. I mean, I just find these fascinating, And I actually have to say, Daryl, I think these guys are my favorite right here. And these little guys are really kind of cool.
Uh-huh.
I like these. These things right here. That's a little tiny line that may or may not be a real line of stars. They might actually just be superimposed on each other, so they look like they're in a line, but they might be at vastly different distances from each other. But this is what you get in the Sagittarius star cloud, and it is just so amazing, to see these stars like this. You can always come back to this if you want to see it too, But if we,
I guess it would be fair to say when we're looking at this, we are looking toward the center of the Milky Way, not directly, but pretty close to it, and we're just seeing oodles and oodles of stars in that direction because that's where the stars are more populous.
Yeah, they're in our way.
Yeah.
Yeah. But
you had another interesting line of stars there for a second. Could you go back to that last image?
Sure. This guy here?
2 or 3 actually. If look over to the left right there.
Okay.
And then you've got a looser bunch over there just next to your head.
Oh, right here?
Yeah.
Oh, yeah.
Up and down.
Look at these guys. Wow, those are pretty cool. I like those too.
And you got a big chain of them just to the upper left of that row of 3 that you saw earlier.
Man, up here, you mean?
Down to the left a little bit. Yeah, right there.
Okay.
Right about there, a little bit to the right.
Oh, right here?
Yeah, that right there.
Oh, yeah, you're right.
And the more you look, there's so many stars in the field. I mean, the more chains of stars will just jump out at you now.
Yeah, and I'll tell you one thing, too, which is really interesting, that to talk to all of you, of course, out there. When you look at these stars like this, one thing to keep in mind that I really want to point out and make it clear is when you look at a star like this guy right here, okay, this star right here is an orange star, right? Well, the star next to it is a blue star, okay? You see that blue star right there, and then you got another orange star above it. These stars are probably not close to each other unless they're a binary pair orbiting each other somehow. And we know that this evolution can occur with some stars. We've seen that before. And we know that it happens. For instance, Albireo, is one of our favorite little places that we like to go. Albireo and Cygnus is a beautiful double star. A known double star where the stars are over 5,000 astronomical units apart from each other, but they're still orbiting each other, And it takes, of course, thousands of years for them to go around once, but I think it's really cool. When you look at them. The other thing to notice is that when we look around in here, one of the things you'll notice looking around is that sometimes you see stars that are absolutely bright red. And I mean, not orange like this, but absolutely really ruby red. And those are the famous carbon stars. And carbon stars are really interesting to look at as well. They look unreal. They don't look like they should exist, because they're so red. Now, the reason they're red in reality is because of the fact that these are giant stars, red giants, okay, like the sun will become someday. And these stars, as these red giants, they have gone up a particular path as they evolve. It's called the asymptotic giant branch, the AGB, but don't worry about that. Just think of it as this. When you look at those stars that are very, very bright red, I mean blood red, they really are blood red, you're seeing a lot of carbon soot, okay, molecules, carbon, 2 carbon atoms together, and you're seeing a lot of that in their atmosphere. Those carbon atoms make up the very deep red colors that you see, just because they actually redden the light from the star when it's coming through all that carbon soot. So the stars look very, very red. And you know, when you see a carbon star, you know that the carbon star is probably giving off shells of stuff, shells of material that end up making their way out into space. And eventually, what happens is these planetary nebulae can form, or if the star is massive enough, then it can actually go supernova. And something like that is, a foregone conclusion, for instance, for the star Betelgeuse in Orion, which we cannot see. It's on the other side right now of the Earth and the Sun, so it's going to be in the daytime for us. It won't be out for a while. But Betelgeuse, 750 or so light years away, is really going to go supernova at some point. And when it does, well, we won't know it for 750 years, so it may have already done so. Now, what if it did so 749 years and 9 months ago? It won't be long before we'll actually see this the light that has the supernova information in it. Okay, it's a big light train coming from the star, right? It'll reach us. And I think that'll be pretty interesting to see that. It might show up in our daytime as well. You know? Benjamin, he says something very interesting. He says, I've read that red stars are usually older and blue stars are younger. Correct me if I'm wrong. Well, Benjamin, thank you. That's a very good comment. And for the most part, we can assume that might be true. And in the case of these stars that are born very, very small in what we call luminosity, very low mass stars, the stars may only be 10 million years old and be red. Okay, those are called M stars. Not all of them are that young. They can live trillions of years, but they're like little percolators. They start off as M stars and they stay M stars. And red, these M stars are bright red as well. And we know, for instance, that some of the stars we're seeing in this view, okay, are in fact going to be M stars. We would just have to look them up. See right there, that's that star right there. It's got this blue cast to it. It's very, very blue. But then you have these yellowy ones. We're actually looking at this in white light, meaning we have no filter that we're using right now. If we use a filter and take images, I'll show you what that looks like, and you'll see a very big difference. Okay, so let's get up our telescope control, and we're going to go up 2 filter stops to filter number 2. Okay, and we'll have to refocus because when we use these additional filters, it causes us to have to focus again. That's unfortunate, but that's okay. It's just what happens. All right, so let's go and pull down a star that we can use for focus. That'll do. And now we'll just refocus the star. So notice I'm over here in this section. I'm going to hit this arrow, and you'll see the star change. Okay. All right, we just went past the focus, and you can hear it in the dome. All right, a little bit the other way. Okay, that looks like we may be close with that. Let's find out. All right, and now let's do a 15-second exposure because we're keeping some of the light out. So we're going to do 15 seconds. And we're going to do 15 seconds at 8,000. So this is, you'll notice there's going to be a slightly blue cast to this. And the reason for that is that we're looking at a filter that actually has a little bit of a blue cast that it imparts to everything we look at. Okay, I've just gone red light in here. So there you go. And you can also hear nighttime creatures out there. But you see, the red stars still look red. The blue stars just happen to look a little bluer. So anyway, I just want to say hello to you guys. I'm sorry, I just sort of jumped right in and didn't even say hi, did I? I apologize for that. I want to say hello to Ian Hawks, who was second here over Tara. Tara got here first. It's okay. It's not a race. Hi, Marianne Robb. Marianne Robb is very important to SkyTour LiveStream West. She is helping set it up, for me. She's amazing. She's working with us on this, man. Boundless energy, that lady. And we love her to death. Okay, Gary H., how you doing? And Daisy and Zoe Amethyst are here. Fantastic. It's good to see you guys, too. Trish D., Benjamin Zavella, we talked. Good. And then we have, let's see, who else is in here? Okay. Boy, a lot of you guys keep talking to each other. This is great, man. I love the conversations you have out there. DK is here. How you doing, DK? If you don't, Bob Harless is here. That's good. And if you don't comment, your name may not appear in the chat list of common chatters. So I'm actually going through the list to make sure I catch you. Bobby Burgess, Governor Z is here. Nice to see you guys. Kathy Pernisek, how are you? I don't know if Amanda was affected negatively by it. I don't imagine she would be. Justin T is here. Gina Leone. Hello, Gina. My business partner's last name is Leone, by the way. Gaia Savelas, how are you? Nice to see you. And Tim F. Woohoo! How's it going, man? That's his buzz line. Every time we talk, it's like, woohoo! That's cool. Yeah, so we're having a good time. My daily side is here. That's nice to see you, too. And Blues Traveler, welcome. Rockstar, man, you guys, you're coming out. This is fantastic. But I'm just thinking with such a beautiful screen, it's like, give you a chance to look at it. So I'm doing the call outs for you now, And if I missed anybody, I apologize. Not intentional. But and Starseed is here now. Hey, Starseed, how are you? Okay. And she's a real nice lady. And Terry Groff, hey, how's it going, man?
James Dugan's here.
Where is he? I missed him. Oh, there he is. James Dugan from Down Under. How you doing, James? Yeah. James is here with us as well. That's cool. All right, yeah, so this is the Sagittarius Milky Way, looking almost near the Sagittarius star cloud. And the nice thing about doing what we're doing is that we're giving the clouds a chance to leave. And as you can see, when they leave, we get some good views. Okay, let's go over back to our view here. And let's go to our planetarium view. Okay, and let's pull out a little bit back and see where else we might go. I wanted to look at something earlier. Now with the full moon up, I'm using this particular filter because that's going to make it easier for us to see fainter objects. It won't be perfect, but it'll make it easier for us. Let's go take a look here. Actually, I think that we might be able to just make our way over there, Daryl. So I just zip on over. So I'm going to go eastward a little bit. And we should see that we're going to come into a very rich area. This should be pretty rich in here. I think it will. Well, let's try it. So this might be a rich cluster as far as I could tell, but I want to just see for sure. So I should still have my guide star, but we'll have to see. So we take a picture at 15 seconds and we'll go see. Daryl, I know you want to see a couple things. I know you do.
Oh, yeah, you sure?
I know you do.
I was sitting here wondering, I know you're 2 hours ahead of me. Is down around the scorpion's tail and the spout of the teapot too low for viewing from your location now?
We're going to check.
Okay.
All right.
I know we talked about one object that we haven't looked at yet, and there's a couple of other good ones down there that I don't know that we've ever checked. M6 and M7.
All right. Sure.
They might be too low now, though.
Maybe, but we'll check it out.
Okay.
Okay, so what I look at was I actually happened upon this really cool double star, and I noticed a couple other things in here which I think are important to point out to you while we're here. The smallest things are just so incredible. Like, okay, for instance, all right down here. Let me first of all, let me maximize this for you. so we can see it. Okay, right down here. All right, let me get to where it was. Here it is. Okay, look at these two stars right here. These two stars right next to each other. All right, these guys may just be line of sight binaries to us. All right, but I mean, it looks like a optical binary. It may not be actual binary, but you'll notice this star is red, and then we got this star here, which is actually more whitish. It's slightly blue, which means it's probably white because of the filter. All right, but you notice a few other things too in this field, or in the overall field here. You'll see that there are stars that are actually very much more red. It's very likely that we're actually seeing a couple of carbon stars. And one, for instance, might be like this guy right up here. Let me show you. This guy. This one might be a carbon star. All right. And he's very red. And he might be even redder if we can actually, focus on him for a while and check him out. But there are carbon stars, and I will show you some more of them. Another one over here. Okay, this guy right here. This is a carbon star potentially, or it might be just a red giant. We don't know. I have to check it out. But I think that we're looking at a very, very rich area in the galaxy. Here's that cluster I was trying to look for right here. So we're going to go up to that right now. I'm just going to grab my controller. I know we're not quite where we need to be right now. And I'm going to move us up there. So here we go. Okay. Let me just bring it back down just a hair. Okay. And now we'll go 20 seconds. Remember, we have a nearly just past full moon. So it's a bright sky, but we're going to try and catch some of these objects anyway. So this is the guy we are looking at right here, and it's going to probably be down about here now. Okay, maybe a little lower. Okay, so we're doing 20 seconds now at 8,000 ISO. The ISO is the sensitivity of the camera. You've seen cameras, they go to, there it is. You've seen cameras, they go to, God, that's beautiful. They go to, 6,400, or 8,000. The cameras we use go to 409,000 sensitivity. Right, and with that comes additional grainy looking imagery, but we try to split the difference. Like, this is beautifully splitting the difference here. I mean, we got these beautiful stars here, and you'll notice everywhere you look in this universe, you will see these beautiful red stars. Okay, now they could be red giants. Okay, like this one, right here. They could be red giants. Or they can be the beginnings of carbon stars, or they can be M stars that are closer to us. M stars tend to be very faint. In fact, they're so faint that they're the most, besides being the most populous star in the entire universe, there's more of them than any other kind. And besides having more planets around those than any other type of star that has planets, you can't see a single one with your eye when you go out at night. Even from the darkest spot you've ever been, you never see an M star with your eyes. All right, not to your eye. You have to use a telescope. Now, like this right here, that star right there, that could be a carbon star potentially. Yes, Daryl, go ahead.
Barnard Star is probably the most well-known M star, isn't it?
Yeah, pretty much so, because it's moving so fast. We actually we looked at Barnard Star. Barnard Star is a star that's a red star. It's a red dwarf, I think, and it's actually moving quite fast. Now, you might think that the stars stay there forever in their places, but they don't. These stars are all moving. If you could see this in fast motion, it'd be going like this. It'd be going like all kinds of strange motions and circling each other and in their general orbit around the center of the galaxy. They go around the galaxy and then come back around. We've done the same thing. We've gone almost 20 times around the galaxy. How about that? Since we were formed. So that is pretty cool, And Benjamin is right. The Perseus meteor shower. Yep, that's right. And boy, wouldn't it be fun to get a Perseid coming through? Now we have a tight view, okay, a fairly tight view. But you know something? We have caught meteors through here. We've caught satellites, of course. I'm surprised we haven't seen any satellites yet. Normally we see satellites. But usually when the full moon is out, I can actually, right now, I could probably photograph the geosynchronous satellites. And what you do is you take a deep exposure while you're guiding on the stars. But the geosynchronous satellites are like that altitude and azimuth line we talked about. They follow that. They don't follow the stars. So they would actually leave a trail on the view because we're following the stars. If we were following the satellites, or if we didn't do anything and just pointed our telescope without any power on whatsoever deep into the sky and took a long exposure, we would get a bunch of star trails. And then you'd see one thing, perhaps, where there's no movement at all. It's a star that looks like it hasn't made a trail. That's the geosynchronous satellite. There's two different ways to see it. Okay? Like this view is kind of cool. We can try something here to show you what I'm talking about. I think you'll like this. Okay? So now what I'm going to do is bring up our system here, and I'm going to shut off the tracking for just a moment. Okay? So there, we're not tracking now. All right, and look what happens. Okay, we got to let the telescope is struggling to keep guiding on those stars. So I've just spoiled it, and now it knows it's not going to be guiding anymore. So here's what I'm going to do. Now I'm going to take a 20-second shot at 8,000. While the stars are moving, they stop moving during the exposure, just so you know. The screen freezes on that. And now you'll see something else. You're going to see a bunch of little lines. Okay? Now, if there's any lines in there that are solid and round and not moving, well, then that'll be a geosynchronous satellite. Okay? Look at that. That's what it looks like when you get a shot of the sky. Now, that's when you turn off the tracking. But one thing to notice is this is how you also can study the star colors very well. Because doing this will show you that you can see the colors, and like you look here, and this is a bright blue star. This is less bright. Here is a star that looks like it might be kind of on a red end. Here's a very bright orange star, all right, and here's a nice red star over here. So you see all these different star colors, and there's a million of them. It looks like you're screaming through something. It's moving fast, you know. But if we come back to our view, you'll see that the stars are just drifting slowly because we're not following the Earth's rotation. All right. If I turn back on the tracking, you'll see that these stars, and I'll put the cursor there so you can see. You can't see this one. Okay. You'll see that the tracking has started up again, and the stars are now locked in position because we're now following the stars across the sky. All right. And so we're counteracting the rotation of the Earth. And you see these so clearly, and Tara's right, you know, we see these so clearly when we look at the colors, and you see them in the streaks, in these time-lapse shots, and these exposures that are longer without tracking. All right. Now, if we were to go up to, say, let's try 30 seconds at 8,000. Okay, this will be a 30-second shot. Now, it's tracking now, and I haven't tested my tracker tonight. You know, each night you have to actually try to tune the tracker. I haven't done that yet, so I'm not sure if it'll be a perfect track. I mean, some nights I can do 4 or 5 minute shots with no problem, and those are in the nights when I've taken the time to set up the tracker to work right. And tonight I haven't actually done that yet. I may still do it. And you're here with me to do it with me. But look at that. Holy cow. And Daryl, look at this line over here, huh? Inside that cluster. Look at that.
Yeah, I see that.
All right. Do you folks see that? Look at this line right here. Isn't that pretty? It's like, hey, look at me, look at me, look at me. That's so cool. And I'm trying to do it this way. You can see this little line of stars going right there. that was loud and obnoxious.
Oh, what was that?
I kind of live in a neighborhood with some yahoos. So it's kind of a yahoo. But new neighbor likes to impress the neighbors. So you can see this beautiful line of stars right here, and that's really, really pretty. I really like that, and so looking around elsewhere in the view, you can see more of that going on. And the longer you look, the more you'll see, Yeah, just as a kid, I never got tired of looking at the sky like this. I never got tired of seeing this stuff. Never. Don't know why. I don't know why I was so fascinated, and you guys have heard this before. I always knew I was going to be an astronomer from age 9. Age 9. So it did sound like a dinosaur, Gina. So it is kind of interesting that we can just explore the Milky Way and look at the stars. Gosh, it's so pretty, really pretty. And I guess my guiding is actually pretty good tonight. The auto guider is doing fine. So that's just beautiful. Now, Daryl, you had mentioned, since it looks like the clouds may have abated, we can try going down to find what you asked for. You asked about the scorpion's tail.
Yeah.
Yeah, we're talking down here, aren't we?
Okay. Yeah, that's Shaula and Lasat, the scorpion stinger right there, I think.
Yeah.
What I was wondering about was there's Shaula. M6, M7. I'm not sure what stellarium would call them. They're down pretty low. They're sort of between the tip of the scorpion's tail and the tip of the spout of the teapot, I believe. I haven't looked that way in a while.
Well, let's see.
I want to say one of them is called the jewel box cluster.
I think you're right.
They're both star clusters.
Yeah, and I think it's M6 that we're looking for. Oh, that's the butterfly cluster.
Okay.
Want to try it?
Sure.
All right, we're gonna go try it, folks. Watch the main view here, and you'll actually see the stars zip away. And then we're gonna end up. The telescope goes to a bright star in the neighborhood, and it will try to. That's the telescope. And then it will actually bring up a star in that it's going to use as a guide star. That's the one, not a guide, but a waypoint star. It's going to put it here, then it's going to bring it down to the middle, and then it's going to take off. All right. So it does that in order to locate the object. So once it figures out where it is, where the cluster is, then you can kind of hear it. And I'm seeing, well, we're seeing something here, Daryl. Looks like we got somewhere near it. Okay. So I think we got it. We're here. So all I have to do is bring it down a little bit more. It looks like we might have some dome in the way here. Then you'll notice this red glare. In the dome's red glare. Yeah, so you'll see that when I pump up this stuff, you see that red view. I have a red light on inside the dome, and that red light is a warning light, which tells me that we have a dome in the way of the shot. Out in Arizona, we're not going to have to worry about that because we're going to have the entire roof just goes off the observatory, so there's nothing in any direction that's going to block us. And I cannot wait for that. You have no idea. And if you talk to Marianne Robb in the chat, she will tell you also that she can't wait for that either. She's really anxious to see what it's going to do. So, but we can try to check out the butterfly cluster here anyway, Daryl, and I may have to just move the dome a little.
I don't know if it's worth the bother or not.
Well, let's find out.
If it shows up, that's okay. If it doesn't, I'd say go back up a little bit higher.
Okay, no problem.
Better alignment with the shutter.
Yeah, that's okay. I mean, I don't mind. I'm gonna make this just a 15-second shot at 10,000 just to see. I think I have a red dome in here, but let's find out. Okay, so we're taking a 15-second shot, and we come over here, and instead of this beautiful background here, it's going to go away, and we're going to see the butterfly cluster, but we're also going to see probably a red, hazy background, Yeah, and that's the butterfly cluster, but that is also the red light of the dome, warning us that the dome's in the way. It
That
is.
is a nice cluster.
It is a beautiful cluster. You know, if you'd like, I can go move the dome. We can actually go for it.
You'll have to move your dome again probably when you move back up.
Yeah.
You can if you want.
Well, tell you what, let's do it after. If we have time, we'll do it after. What do you think?
All
What do
right.
you say? Hello there, Cindy Murphy. Nice to see you.
Hi, Cindy.
Just so everybody knows, I and this happens with Daryl and me and everybody who joins us. I tend to do my best to say hello to everybody because I think that if you took the time to get here, then I want to take the time to say hi to you, at the very least, okay? Because I think you've earned that. Let's try going up to the lagoon, shall we?
I knew you were going to say that.
You think you did, huh? I just got to show the nebula. Why not? I mean, we're okay. And now we're going to go to Al-Nazi here. Al-Nozzle. The star in Sagittarius is the one that is the spout. It's the tip of the spout in Sagittarius. There's the centering process. It goes to center it. And then just when you think it's going to stay, it goes and just gets blasted away. Watch. And it centers it up, and it's like, okay, I got you. I know where I am. And then the telescope should race off now to the Lagoon Nebula. And there we go. And you'll see the Lagoon cluster coming in. And there it is, right there. That's the Lagoon Nebula cluster. Now, I can tell you, we can take some photos. I can show you what the different filters do. And you'll see the difference. And that's actually, I think, very helpful to understand how it works. And so we'll just wait here. The telescope is getting its guide star. I know that's where we want to be, so I can tell it, yeah, we're there. And then I'm going to move us a little bit toward the west. And that's it. And now the telescope, you have to wait exactly 11 seconds, maybe 11 to 12 seconds at the most. And the telescope will have a guide star. Once it has a guide star, it can stay locked on, okay? But it needs the guide star to do that. There's a whole second telescope up on top, which you saw in that original photograph, which was this one, okay? This is that second telescope up top is actually a guiding telescope, which actually guides the main scope. So it's really a pretty elaborate setup. Okay, now let's do I will do 20 seconds at 10,000 here. Okay, this is with filter. If you look down here, filter number 2. It's the wider narrowband swath through the spectrum of this nebula. Okay, so 20 seconds at 10,000. And what are we going to get? I don't know, Captain. What are we going to get? Well, we might get dome. We have to be. I might have to move the telescope, the dome rather.
So that does look like a butterfly.
I guess it does. See, like here's one wing, here's the other, right? Dun 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 dun. Dun. Well, it's going away because the lagoon's coming. Oh, look at that! No dome. Yeah. So here's what we got, folks. Now, keep in mind we have a nearly full moon out, and we're able to see a lot of detail in this nebula, okay? Now, I only did a very short exposure, all right? We also see something else, which I warned you that we were going to see, okay? What is this? What is this? What is that? What is that? And there's one there and there's one there. Do you see that? Dash, dash, dash. See the lines?
Yep.
Okay. What you're
Tumbling
looking,
satellite.
you got it. What you got there is what we call a tumbler. It's a tumbling rocket body. So sometimes when rocket bodies are left in space, okay, this little bottle will work. They go like this. They rotate through space. They catch the sunlight, and when they catch the sunlight just right, you see one of these dashes. And then as they rotate like lengthwise or toward you, they go away. You don't see it, but then they do this, and you see it. And then they do this, and you don't see it. So as they tumble, you actually see and lose the satellite. Isn't that cool? So that's a tumbling rocket body. At the MUFON boot camp, I think it was 2 years ago, I showed people a tumbling rocket body because they thought they were seeing a satellite that was responding to them when they would hit it with a laser pointer. And I said, no, let's give that a shot. And they thought it was coming from all different places in the sky. But when we looked at, when I actually was taking a picture quietly with my camera while this was happening, and they said it was coming from all these different spots in the sky. And when I showed them the photo, they saw dashed lines, much like we just saw here. Okay? They saw a line. They saw these dashes of this tumbling rocket body. And none of them realized that until they saw the photo that this was actually all in the same place. It was just moving in a slow line. The reason has to do with the way the eye sees things at night. The eye doesn't have a good way to pinpoint stuff in a sky where there's no reference points. And stars are not good reference points. So when they look at these objects in the sky, they see a pinpoint and they go, hey, what was that? It was over there. It was right there. Then they see it again, and now it looks like it was over there, and then over there, then over there. In fact, it's in a very long progression of lines. It's a very, very simple thing to see if you have a camera. But when you have your eye, due to something called the autokinetic effect, your eye cannot remembers basically the last position it really saw. And so it looks like things from all over the sky. And Tara remembers, she was there, right? She was there at this boot camp. That's correct. So let's take another photo, and let's actually go to, say, 25 seconds, and let's go up to 12,800 ISO. So now we're entering the realm of real darker night sky photos. And most of the moonlight's going to be taken away. And we will see some blue from the moonlight that bleeds through from the filter. But mostly we're going to see this nebula. Incidentally, taking photos of nebulae like this is next to impossible on full moon nights when you don't use a filter. Okay, see, we got part of the dome in the way, Daryl. Yeah, part of the dome's in the way. I have to go move the dome. All right, now, mind you, I won't have to do this in Arizona. Okay, Daryl, can you entertain, do a dance? I mean, you remember that song number you said you wanted to sing?
I did.
Yeah, it's called Talk About the Nebula. I'll be right back, okay?
Okay.
All right, thanks, Daryl. Hang on,
Sure.
folks, I'll be right back.
Let me clear my throat here. Merle Ravenscroft, many brave souls are asleep in the deep. Me. Many brave souls are asleep in the deep. So beware, beware. Sorry, I'm out of practice, and I can't hit the low notes like I used to. That was where was that? Thurl Ravenscroft. Merle Ravenscroft? Merle Thurl. I want to say that was on an old Little Rascals episode. One of the kids sang it to his song. That or Three Stooges or something. Let's see, what else? I'm not going to sing anymore. I won't put you through that. We've had a pretty good progression of storms here today. Nothing like what Bill or Mark had back east. Just more generic afternoon thunderstorms. But there's been a steady run of them, and I've had some thunder in the background. One reason I've been trying to stay on mute when I'm not talking. And Mark is back.
That's okay. I was letting you bond with our audience, Daryl. You always do such a fine job.
Yeah.
Okay, 25 seconds.
I sang him a song.
Oh, I missed it. Yeah. Hey, folks, show Daryl some love. The guy's got just a great heart, and he's really, really good in astronomy. He doesn't like to be complimented, but you know what? Too bad. He's a really good guy. So hopefully, you guys can appreciate him as I do. Here you go. Now, see. Go ahead, Daryl.
Humbug. Humbug.
Yeah,
Humbug.
yeah. Well, it's not even Christmas. You can't say humbug yet. Okay, check that out. So there is the Lagoon Nebula. Now, what's interesting about the Lagoon Nebula is that right here in the middle of the Lagoon Nebula, and I can zoom in more, okay, but then you start seeing the noise of the camera sensor. But you know what? When we process these, we get rid of that noise. We actually can remove it. I can remove almost all that noise. So in the center is this hourglass shape. Very famous location. And right next to it is this star. This is a star that's extremely hot, extremely young. It's probably only a few million years old. And it won't be around for many more millions of years, okay? It's going to be around for just a few more million years. And then it's going to go supernova. So it's a very hot O-type star. O-type stars are the hottest stars. They give off a lot of their radiation in the ultraviolet because they're so high energy. And they can give off even higher energies as well. But this nebula is powered by that O star right there. Now you see it reaches light years. Okay, this reaches light years out. That's how powerful the radiation is. So clearly no life like ours could survive in this nebula right now. But in the future, this star may migrate away, it'll go supernova, and then this entire area is going to be full of just all this material, debris, and star stuff, as Carl Sagan used to say. You know, we are made of star stuff. Okay, he was my favorite astronomer, and he is right in that this whole area will then have all this material in it. Now let's just go back for a minute. I want to take us back, and I want to go to filter wheel number 1. This will be the narrowest view, and I'm going to go to 30 seconds. I generally go up like 2 stops for each time I bring up a filter. And we'll see if we get about the same. Okay, 30 seconds at 16,000 ISO. And now this is with the very narrow band filter. All right. And the very narrow band filter also has its own problems that it has with noise. But I want to show you how that view looks compared to this view. Hey, Papa Tom. Thank you. That's very kind. Yeah, if you guys like what you see, thumbs up is wonderful. I have no issues with that, of course. Why would I? You guys are very good to me. Okay, now look at that. You see the difference? Look at that, Daryl, huh?
Uh-huh.
Okay, this is what the narrow band filter looks like right here. Okay, the ultra narrow band looks like this. The somewhat wider narrow band filter looks like this. Which one looks better? No contest.
Tonight, I'd say that one does.
Yeah, no contest, right? And by the way, the night is kind of a crappy night out there. I don't have a very good sky right now, and I do have clouds poking around here or there. But still, look at what we did with the lagoon. This is gorgeous. Actually, it looks really nice. Holy cow. Let's zoom in on this. You'll see there's still some noise. Okay, we've gone up by 2 stops, and we actually did really, really well there. Look at that, though. That is really... we're seeing a lot of detail now that we just wouldn't see. Now, let me show you what happens when we take the same photo. All right, but now we're going to actually take the photo in the visible light, okay? So what does visible light mean? Well, the visible light means there's no filter in there, and this is what we're seeing, okay? We're looking at it now with our eye. And now I'm going to come down 1, 2, and 1, 2, stop. So we're going to go down to 20 seconds at 10,000. All right, because now we don't have any filter. Okay, now we'll do that, and I'll show you what we see.
Mark, would you excuse me for a moment, please?
Sure, of course, Daryl. So this 20-second photo is going to show you the difference, and we'll check it out in just a second. You will see a difference now between this and the non-filtered shot. Just so you see how filters look. Okay? Look at that. This is the unfiltered shot. This is the filtered shot. Okay? Now, and then this is also a filtered shot. See, in this one, we see the blue of the moonlight because there's a, like I said, it's a wider narrow band slot through the spectrum that we're looking at for this nebula. But this one over here, this is a narrower, okay, a narrower slot cut through the spectrum in various places. And in other words, even with the full moon out, nearly full moon, we can still take pictures of nebulae like this. This is amazing. It's just beautiful. I'll take one more with the I want to put that filter back on. Let's go back up to filter 1. Okay. Filter wheel 1. Oops, sorry, I went the wrong way. All right, and we'll go to 1. And there we go. Okay, and now what we're going to do is we're going to stay at 10,000, but I'm going to actually go and I'm going to go to 1 minute. I'm going to see what I can get with 1 minute. Now, I have some clouds out there, so we're going to see if that's actually going to work. So when we look then at these objects, okay, I have to specify too. This is the JPEG image of the shot. This is the raw image. Okay, this raw image looks like it has this more noise in it like this versus the JPEG. And it does, but the JPEG actually, this is the raw and this is the JPEG. The JPEG image actually loses some data. It sort of smooths the data, okay? And the raw file has much more data in it. So you can see sharper details and so forth and more details in these dark lanes. Look at these dark nebular lanes in here. They show better to the eye in here, okay? But you never process the JPEG. You always go to what we call the raw file, because this is the unadulterated, uncorrupted data. It hasn't been manipulated in any way. This is straight out of the camera. All right? Straight out of the camera. So it's really something else. You know, and that straight out of the camera shot is the one that actually gives us most of the data we need. Okay? These JPEGs may look nice, you know, initially you say, hey, look at that. But this is the one that you would take, say, 20 of these and stack them together. And you get these phenomenal shots. So we're doing a minute shot on the Lagoon Nebula right now with our very, very high-end filter. And just to give you an idea, okay, the filters we use are not just ordinary filters you can get in a camera store. These are specialty filters that you have to order. I got 2 of these, and they came from, gosh, I think, can't remember where it was. It took several weeks to get here, actually, so I think it might have actually come over on a boat. Okay, all right, and then, of course, when you have just visible light, you end up like this, and it's just, that's the moon. The moon is doing that. Remove the moonlight, look what you get. Isn't that incredible? You know, and we're still doing a 1 minute exposure here. We're still waiting for that to come back, and it's still going, so we're not ready yet. And when it shows up, we're going to see more stuff, and if the guiding is good, it'll show up really sharp. If it's not good, then it'll have moved a little bit, and that'll be my fault for not tuning the guider better. I didn't tune it at all tonight, so that's my mistake. Oh, look at that. No tuning required. Holy cow. Look at that, guys. Hey. Look at this. This is the this is 1 minute on the Lagoon with this filter, you can actually see this dark material in here very, very clearly and very, very nicely. Yeah. Now this is the JPEG, as I said before. This is the raw file, so it's going to look noisier. Okay, but look at how it, look at all this material. Look at how you can see this dark, sinuous lane of dark dust over there. Now I can remove all this noise you see. All this noise, this is called color noise. I can get rid of that. I can get rid of the noise and make this look like it's supposed to look. And I've done that, and Daryl's seen some of the shots. They've just looked, they've come out beautiful. You know?
Yes. You did a stacked composition of several exposures of the lagoon recently, I think it was. And
yeah, I did 8 shots.
Yep, little dark globules came up all over it.
Yeah.
Very crisp. Very
Yep.
nice picture.
Yeah, I can see if I can find that image for people to see if they want to see it. It really is beautiful, the Lagoon Nebula. And I'll show you some of the others too. I'm going to show you the lagoon now, but I'm going to show you what happens. Okay, this is... let's see if this is going to bring it up. Not that one. Let's see. Oh, it had... Oh, I get you. Okay, so this goes away. Yeah, there we go. So this is actually what the Lagoon Nebula looks like when you do processing on it, and you can actually see this tremendous, this really outrageous that little thing right there. That's the thing I was just pointing to in our raw shots. So when we look at the raw data, okay, the raw data that is like this data here that I was telling you about. We're looking at this guy right here. That thing right there is what we see when we look at this. That's this guy right here, you know, that you can see. This thing. So look at how it looks when you actually take the time to do the processing. All this subtle clouds down here. It looks like you're looking at clouds on Earth. You know, you're looking at, you know, the starlight that is actually causing these clouds to glow because they're hydrogen gas. And the hourglass shape over here, this is the thing that we talked about before. This shape right here, this hourglass, that O star is the thing which is powering this whole nebula. That it's just an amazing thing. It's these are really, really, you know, excellent pieces of equipment to use, you know. And like I said, when we get to Arizona, I expect that almost every shot we take is going to be stunning. And I would think that Daryl would expect it to be too.
Heck yeah.
Yeah. So yeah, that's the lagoon. And as Daryl said, he knew I was going to do it, and he's right.
I bet I know what you're going to next also.
Oh, no, you don't.
Okay.
You know why you don't? I know you think
we'll see.
You think I'm going to the Trifid Nebula, the Trifid, yeah.
It's only logical, Captain.
Yes. Logical. Eminently logical.
Whoa, did you hear that?
What's that? Thunder?
Just out of thunder.
Oh, I did not. No, we're gonna go somewhere else.
Okay.
Yeah. And I'm going to take us to filter number 2 as well. Okay. And we're lining up on Caus Borealis right now, which is this star down in... oh, you can't see it, can you? Hello. Let me get you to see that. Hello. There we go. We're lining up on Caus Borealis right here, and there it is there. And then once it's centered, we're going to be shooting off to another location, which is right up here.
Caus Borealis is the top of the top of the lid of the teapot.
There you go. And there you can see the teapot, as Daryl was talking about right there. Here's the handle of the teapot. Here is the body of the teapot. Here's the spout. And here's the top. And Caus Borealis is that star right at the top. And now we are over here at this location here. Let's find out what we're looking at right here. And we're at filter number 2, the somewhat wider narrowband filter. Okay, and we're going to do 20 seconds at 8,000. We don't need to go to 10 with this. And here we go. Not sure if we got our guide star. It takes time sometimes for the guide star to come in, but we should get it. This is the observatory view that you're seeing here. Okay, so we can actually show you what's going on in the observatory, and we're able to move. Wow, look at that. What are we seeing here, folks? What is this? Well, this is one of Daryl's favorite clusters. See, I told you didn't guess.
Yeah, M22.
You got it. Messier 22. This is a huge globular cluster. It is a cluster that is about, I'd say, it says it's telling us it's only 9,700 light years away, but they generally tend to be between 10 and 35,000 light years away. Is M22 that close? It could be. I'm not sure. I don't remember. Daryl, you may know. I don't remember exactly.
I'm sorry, what was the question again? I was reading chat.
No, that's okay. How far away is it? I thought it was like it's just under 10,000 light years.
I always thought it was like 20,000 light years away.
Yeah, I mean, what's given in the planetarium, I think, is not correct. It says it's 9,786 light years away. I don't think it's 9,700 light years away. I think they're always much more than that. If it was 9,700 light years away, it'd be a lot bigger in the sky, I would think.
Yeah. Terra, that red glow is probably the filter tinting the stars. It is a globular cluster. It is one of my favorites. It's not as showy as M13, but it's a very pretty cluster.
We can make it showy.
Sits above the left-hand corner of Sagittarius, the teapot, where the handle and the lid come together. It's up close to what's called the teaspoon, which sits over the top of the teapot.
That's right. And if you need to see where that is, this is the top of the teapot here. Here you see the teapot, the handle, the body of the teapot, the cover, and the spout. And just above the top is right where we're looking, right here, the Great Sagittarius Star Cluster. Yes, sirree, and that is the most amazing location. Okay, and I just synchronized the planetarium. So now we actually see Messier 22, and that's in the light of our second narrowest filter. So you can see now, when we looked at the Lagoon Nebula with the darkest filter, see the sky looked like this. Okay, well, like that roughly. And now we're looking at this with this cluster here with that second darkest filter, so that brought us a view more like this one for the Lagoon. All right, as opposed to this one. So if we were to bring in the other filter right now and do another shot and go up by a couple stops, like let's do that. We go to filter 1, all right, and you'll see the filter now will go, it's moving, and now it's 1. And if we go back to our main view now, our excellent, exciting view, then we can actually go up by a stop, another stop, and get the same type of view. This will be 30 seconds at 16,000 ISO. Again, this is on a nearly full moon lit night. And for us to get the kind of results we're getting is testament to the fact that we have some really, really nice filters working for us in the telescope right now. You know. And these stars, all these stars, okay, that you see here, these are all stars that are interacting with each other. They're gravitationally attracted to each other and bound. So they're actually orbiting each other, okay? As you can see, I could have gone a little longer even on that exposure. I only went 30 seconds. I could have gone even more. But these stars are actually gravitationally bound. They're orbiting each other. Let me go back to this one to show that. So they go in and out. If we could see this thing in like some kind of accelerated motion, we'd be seeing this stuff going on. These stars will all be doing this. Then every now and then you see one get ejected, another one, and these are called halo objects. They're outside the galaxy, orbiting outside the galaxy. Okay, and as they come through, they plunge through the disk of stars. And then they come up through the disk of stars on the other side, potentially. They actually can orbit. They can actually have stars pulled off of them as they come through. And they can actually have stars that join them as they come through. So we might find some oddities in some globular clusters. Things like we might find planetary nebulae in globular clusters. There's only like 4 to 5 globular clusters that actually show these end states of stars like the sun. These stars in the globular cluster are amongst the oldest in the universe. They were pretty much formed early on, so they're fairly old stars. All right. Now, stars like the sun will live around 10 billion years or so, and we're about halfway through that. So don't pack your bags. No need to run away yet. And then stars like these, okay, these stars are stars that are all fusing hydrogen into helium and have been doing so for a long time. They're somewhere around 10 to 12 billion years old, and they've been here just after the universe began. Okay, I guess a billion years after the universe began, they formed, and they're really old. They're very old stars. We actually found planets that are 12 billion years old. So we know that the universe made planets way back in the beginning, and it continues to this day. So it's a sliding window of planetary formation, sliding window of star formation. Everything is ongoing in the universe. Now, certain nebulae no longer make stars. These are stellar nurseries, like the Lagoon Nebula we talked about. These are stellar nurseries. All right, this is a cluster born of the Lagoon Nebula, and some of these stars are born in the Lagoon Nebula. And as they move away from each other, then this whole area will become a fertile location for new stars to form and possibly planets. Once this O star goes supernova, there will no longer likely be a major ultraviolet radiation source here, other than, well, potentially a neutron star or a pulsar that's left behind at the end of this. But after that, the bottom line is this stuff it'll go dark. This will just end up becoming dark. Some of these stars may be helping to illuminate this nebula, but as they migrate away from each other, it becomes a fertile breeding ground, just as our early solar nebula became a fertile breeding ground for new stars as well, and became, we still had our sun and all the planets, and possibly some of the stars that comprise the Big Dipper may have been in our original cluster when we formed in a cluster ourselves. Not all stars form in clusters, but they think maybe we did, and that's really kind of a cool thing too. So here's what I'm going to do. I'm going to go back to filter wheel number 2, and I will take another shot with this new setting. We'll leave it up to 16,030 seconds. All right, and then after that, we'll go to the item that you knew I was going to go to before, Daryl.
Okay.
Mm-hmm.
grumble, grumble.
No grumbles. It's great.
I learned something interesting about M22 just now. You've
What's that?
talked about before. M22 is one of only 4 globular clusters that actually does contain a planetary nebula.
Yeah, there's like well, they thought there might be 5, but it could be there's only 4. But yeah, but we can't see the planetary nebula from my understanding because it's really kind of small,
This is correct.
and so it's kind of hard. I don't remember exactly where it was, but it was one of these quadrants, if I remember right. It was sort of
Yes.
in here
Yeah.
somewhere, and I couldn't really.
It is very small. We can't see it.
Yeah, I
It was discovered by the IRAS Observatory
yeah.
back in the day.
That was the infrared astronomical observatory.
Uh-huh.
Yeah, this is it. So this is Measure 22, a collection of all these stars. And when I was talking about the planetary nebula, and I neglected to mention that M22 was one of the candidates, I was talking about the planetary nebula being in globular clusters. But I didn't say that M22 had it in there. But thank you, Daryl, for finding that. But they are rare because the hard part is to try and understand, if the cluster was born at the same time, all the stars are around the same age. So if we see one planetary nebula, statistically we should see 100 because many stars are undergoing that late stage evolution at that point. But why would we see just one here or one there? It doesn't make any sense. And the reason it could be that way, the reason we could be just seeing one, is because maybe it was grabbed when it went through the disk. When it went through the galactic disk, it could have been grabbed. It could have grabbed this star and left, a planetary nebula, dragged it away before it became a planetary nebula, and it became one after it entered the cluster.
Makes sense.
Yeah, but things that make sense aren't always the case. So I'm just spouting a theory of my own. I don't know if it's really true. Honestly, I had Kyle Lynch is here and Gas Mask. Hey, guys. So
David Schmidt is here.
And Dave Schmidt's here. All right. Governor Z-Ray, every time you make a comment, and they're good comments, but, for some reason we have to keep clicking a button to let you bring your comment in. You're not saying anything bad. I don't understand why it's making us do that. Yeah, and Dave Schmidt's in Bangkok, in the Bangkok area, and over there in Thailand, it's 11:25 in the morning. There, I believe, David. So you've got you're getting ready to go to lunch, and a lot of us are getting ready to go to bed. That's so cool. So let's see. Okay, so this is Measure 22. And now if we want to just go poking around a little more and see what else we can see, I did say that I was going to go to something else that I thought was pretty cool, and we're going to. And I just have to make sure that I bring us right to it, and let's just hope I don't have to move the telescope again, or the dome. So I hit Control of the telescope and move us over, and now our telescope is going to go. I wonder if it's going to go to Pallas. Is it going to Pallas? Well, it's centering a star for sure, but it doesn't look like it's Pallas right now. What is it? What star is it centering? Ah, okay. It's doing Al-Nazl again. Tip of the teapot. And then it's going to race up here. See, Al-Nazl is centered. And then you're going to see it vanish as it goes, as the telescope starts taking off again. There it goes. Okay. And we got clouds apparently.
Bummer.
We should see it right here. I mean, but I think that we may. I think we may have missed it because of the clouds. Okay, let's do this again. Well, first of all, let's just wait a second. Just a second. Okay, so we want to go there. Okay, I'm gonna bring us up to the Lagoon Nebula again, and then I'm gonna just head northwest rather, to find the Trifid Nebula, because there were some clouds there. You can see the stars fading in and out. So maybe I can go to it manually. Right now we're actually trying to get, see, I think we're fighting clouds. We should be seeing stars. See, you can see little bits of them. They show through every now and then. And now we're heading up. Yeah, it's just not. Unfortunately, it's fighting the clouds. It can't find it. So what I'm going to do is I'm going to try and find it for us. All right, so first things first. Okay, finding it manually. Let's do this. And see this. We're going to drop this down. Just a quick 10-second shot. I don't think it's there. Maybe it is. We'll find out. That was beautiful, Daryl. The M22 was gorgeous.
It is.
Yeah.
It's one of my favorites.
We're not there. Okay. So let's do this. Let's go and head north a little. All right. First, let's do that. Okay. All right, and just working something manually here, guys. Not a worry. And we'll go west a little bit and confirm where I think I am, which I believe I am. Just do a quick 10 seconds. Actually, this is the first time the telescope's been in operation since the hurricane, and it's actually been doing flawlessly, and there's the lagoon, just like I wanted. Okay, so very pleased that I actually pretty much took it all down and protected it, and in so doing, was able to open it up again today and get it ready for you guys without having to waste too much time. Okay, so what we're doing is we're going up now to this other nebula that's up here. All right.
I think that's pretty amazing.
What's that?
That you got it up and running again so soon.
Yeah,
I was thinking about you yesterday. I imagined, I almost suggested to you that you go to Home Depot or Lowe's and buy one of those blue tarps, get one big enough, you could drape it over the entire observatory and tie it tightly with bungee cords, or have enough skirt left laying on the ground. You could put rocks all the way around the dome to
Yeah.
keep the wind coming under it.
I was thinking about all of that, and I actually had written off the building. I thought the building was going to get torn away, so I figured, okay, I'm going to take off all of the appendages on the scope. Okay, the auto cover mechanism, the telescope on top for guiding, the cameras, the filter wheel, and have just the bare scope minimum left on the platform, on the pier. And I then chose to, instead of taking the telescope just down, I couldn't take the telescope off. It's 350 pounds. And then I would take that telescope and just wrap it in plastic, the same plastic I used to cover it on rainy days. And then over that, I took a blue tarp like you suggested, and I wrapped it tightly around the pier and just made it just a big, giant covered. It looked like I was a bush that you cover with a cloth, And when I did that, we ended up having no issues. And I also covered the computer, which is in an alcove inside the observatory. It's an extended wall. And in that extended wall alcove is this computer system, which does all the control systems. I connect to it directly. You're seeing the image. You're seeing the screen that would be displayed on the computer screen in the observatory right now, because I've slaved that to you so you can see it. And that's what we're seeing. So that said, I managed to cover it up. Oh man, we got dome again. See, this is the problem with the dome. Problem with the dome. Can you hold on a minute, Daryl, so I go move the dome again?
Sure.
All right, I'll be right back, guys.
Yeah, it's always something. When I heard he was getting hit by the storm yesterday, I thought of that, about draping the entire thing with a big blue tarp and anchoring it to the ground at all points around stakes or rocks or something. And then for some reason, it made me think of Leslie Nielsen and Priscilla Presley and the Naked Gun movies. That scene where they practice safe sex, if you know what I mean. Pardon me, that's pretty bad. They were practicing safe habits, you see. I've never used an observatory. I've been in a number of them. Uh, God, just a telescope's bad enough. I'd hate to think of what you have to do to make it security and weatherproof and all that stuff. It's a big investment, big responsibility. That's right, David Schmidt, the body condoms. I see I'm not the only one with a dirty mind.
Uh-oh. What'd I miss?
We were talking about the tarp idea I suggested over the telescope.
Okay.
Or over the observatory. It reminded me of a scene from The Naked Gun.
Oh.
Say no more.
Gotcha. So yeah, in the middle of the hurricane yesterday, we had and Kyle said it too, he had tornado warnings. A tornado warning is after it's on the ground. A tornado watch is the potential for a tornado. We had a tornado warning, so we had one on the ground. Last time we had a tornado warning here. I'm waiting for clouds to clear. You notice the stars get clear, then we're waiting for 2 little stars to show up right here. And when they do, that's when we can take the picture. So I'm just waiting and waiting and waiting. When it comes out, we'll get it. The tornado warning, last time we had one, there it is. All right, I'm taking a picture. Last time I took the tornado warning seriously, we actually had a tornado in the center of town here that came roaring through Terryville, Connecticut. And it ended up ripping the roof off gas station, bringing down trees. We're waiting for a shot to come through. That's why it looks like this, okay? And after it tore down these trees and stuff, it just left a path of destruction. Pretty bad, you know? Yeah, not good. We still... and I see the temperature actually has dropped outside, so we do have to refocus. There's a nebula here that you can't see yet. And the moon is causing a problem with it, too, but Lagoon is actually pretty bright. I'll see, look, it's all clouds, but the stars are all gone here. All right, so we will wait it out, I hope, and wait for this to clear. I have an all-sky camera, too, which is behind me. I took it down for the hurricane. Haven't put it back up because I'm going to pack it up and send it out to Arizona with the computer that's going to run the building out there. And just so you know, hey, Hanahata77 is here. Hello. Hi, Bonnie. The telescope out there is going to have a computer in the building as well, but the all-sky camera will also be hooked up, and we're going to be able to see the night sky, and you'll see the gorgeous Milky Way. And it is really beautiful. But when we look at the night sky out there, there's the area we're going to be looking in. You might notice that you'll see that there's no stars. And you go, well, where are the stars? You know, there's supposed to be stars here. In areas that are light polluted, the clouds look bright in the images. When I showed you earlier the clouds passing in front of the stars and the sky was clearing and you saw the cloud moving across. In Arizona, the clouds don't look like that. In this location where we are, when the clouds are passing in front of the stars, they look black. There is no light reflecting on them like they do here and in other areas in New England. There's no light reflecting on the clouds. They are dark against the sky. The only place I've ever seen that was at sea on my cousin's fishing trawler when I was working on the trawler with him out in the North Atlantic. And that was where the sky was so stunning. I wish I could have appreciated it, but I couldn't, you see, because I was too busy being seasick, to be honest. Okay, so that said, I'm going to bring us into our focus mode here, and I'm going to bring us a star to focus. Probably the center of the cluster is like right nearby here, so let's go there. There we go. Those are the stars in the center of the cluster. Center of the nebula, I should say. Now let's get rid of this for now. All right, and we'll bring this back over. And the clouds tend to make things a little bit difficult to see too sometimes. But let's just go backwards here. Okay, that's out of focus. You can hear a little bit of the focuser in the dome. You can see how it's jumping around. And that jumping around is because of the fact that I'm trying to get the focus, and you can hear that noise of the focuser in the dome. I'm not sure that's good. I'm going to take a real quick shot. I won't get nebulae too much, but I want to see 10 seconds on this to see if I can actually get see if I actually have the focus down. Okay, so we'll go over here and go here, and let's wait for this to come in. Oh, well, that looks better, doesn't it? Okay, so now
A little bit.
Yeah, no, I only did 10 seconds. Okay, so I just had to get the focus. Now that it's focused, okay, we can go back and take a longer exposure, and I'm going to do this. Now we got this. Let's go to filter wheel 1. And let's do 30 seconds, 16,000. Ah, crap. The star went away. Okay, it'll probably be a partial view, or you might get some wispy, what look like nebula crossing the nebula. That's actually it's actually a cloud. Kyle, you're asking about spectrum. You talking about the program, the application? If you are, I have it, yes, but I don't. Oh, okay. No, that's not bad for what we're looking at. The only trouble is that we can't see the upper part here. You can kind of barely see it. Okay. This is the Trifid Nebula, and I know it looks faint, but that's because we're actually facing clouds and a full moon, so not nearly full moon. We should see the stars right here. We're actually picking this out. They're showing up ever so faintly. They're showing up, but we want them to be pretty bright, so we'll see what we're waiting on. And when they come out, all we need is a quick 30-second shot. Because if you're talking about Spectrum, because Kyle says, do you use Spectrum? I think Spectrum is an app on the iPhone that I actually had, so I don't, out of the context, I don't know. You got to tell me what you're using it for, and if it's that application at all. So, Daryl, I was telling you, and the rest of you, I think I've mentioned this before. I used to weigh 198 pounds 3.5 months ago. And I just started drinking water all day long until dinner, and I would eat regular dinner. And I found I had more energy. I was clearer in the head. I didn't have these sugar comas that I would get into sometimes, from too much sugar. No more soda. I haven't had a soda in many months. And I used to love Coke Zero, but now I can look at it and not even want it. And I've actually, in 3 months, I've dropped 20 pounds. So I'm like as of this morning, I was 178. And in high school, I weighed 175. So I'm 3 pounds from high school weight, and I'm going to achieve that and do better.
Good for you.
Well, I say that, but I don't know if I actually will be able to. I'm hoping to, But my point is that for anyone who may have to work out losing some weight, you can give it a try. It won't hurt you. Just drink regular water. You can put ice in it. You can make kind of like light lemonade with little powder things, just a little bit just for flavor. And it's just water for breakfast and all day long while you're thirsty. You're going to go to the bathroom an awful lot, yes. But you know what you're doing? You're flushing out your kidneys. And you're literally cleaning yourself out like that. And then when dinner time comes, you know what you're going to find? You're going to find that you're not going to be ravenous. You're not going to say, I want 4 pizzas. No. You're going to eat, and you're going to find almost right away that you don't want to eat as much as you used to eat. And I think that is something that's going to be the biggest thing you notice. And I've gone down 2 sizes. I'm wearing pants I haven't worn in 2 full years, maybe 3. And I'm still waiting for the clouds here. So so if you're struggling with your weight, and it's not a commercial of any kind, believe me, because this is just for your health. You might want to try that. It's not gonna hurt you. It's not a drug. It's nothing other than just water. And I found when I had heart surgery 5.5 years ago, and I'd woken up, and most of you knows, I woke up as a quadriplegic because it went wrong, and I had to learn how to walk and talk and do and see again, all these things. Well, anyway, the thing that I wanted most of all, I just wanted ice chips. I wanted ice chip, just water, and they would put it on a little sponge, and that little sponge they would give me and go, and that sponge would go in my mouth. I was like, oh, that's so good, and I would just like have that water for just that fleeting moment, and it was so good. So I actually learned, maybe that's what taught me. I learned how to appreciate just plain water, I guess, and so the water thing is something. I learned about this water thing though, not from that experience. I learned to appreciate water better with that experience. Because when you don't have it, oh man, it really does make a difference. But I learned that from a woman that I actually toured Norway with last August, Ket Torbolsen, and she is someone who taught me about the benefits of just drinking water. And I thought she was nuts. I told her so. I said, "No, I'm not gonna just drink water. What are you, crazy?" You know, well, she would just drink water for 30 days straight. That's it. No food, no nothing. I was like, oh, I can't do that. That's crazy. So I didn't do it. And of course, I saw my weight go to 198. And I was like, oh, this is too much. You know, that's the heaviest I've ever been in my life. So I said, all right, I'm just going to try the water. Okay. But I'm not going to do it for days and days because that's just a diet. I want a lifestyle change. So I started drinking water up until dinner. And that made the difference. Because I can look at snacks all day long and say, yeah, I don't want them. Now, it took 3 days. 3 days in one. It took 3 days to get past that desire to eat everything under the sun. And then once I got past that, it was amazing how little you actually wanted it. I made more progress in my work. You know, I own my own company, as some of you know, a visual effects company. We do work for movies, television, and the Navy. Okay, and I've done more. I've got more done with them that company than I've done in probably a full year or 2 years, because I dropped the pounds, blood pressure's gone down, cholesterol's dropped. You know, everything's gone down. So it's nothing but healthy. If anyone needs to, lose some weight, then that's great. If you need to gain weight, like Kyle does, then you might want to talk to your doctor about creatinine or possibly some protein powder drinks in between meals. Make yourself some chocolate milk and put in some of that protein powder as well. Have a nice, protein-laced fatty drink. And you'll pack on a few pounds, I would say. But anyway, I'm not getting my stars in here. I'm still seeing some of it. So let's try something else. I don't like to, but I'm going to have to, Daryl.
Not my fault.
Oh, no. I'm not going to say it's your fault. Let's try to do the Eagle, shall we? Okay.
Sure.
Yeah, we'll head up to the Eagle Nebula. Eagle Nebula is the pillars of creation that you've seen the Hubble Space Telescope took a picture of. And they're just beautiful. Okay, so now we're going to be on, we're over at the star Nu Ophiuchus. And I don't see it though. So the telescope is saying, I don't see it, and it's trying to hunt for it now. So we have clouds out there. If I had the all-sky camera operational, instead of being packed up back here, I would be able to tell you exactly what's going on. I would have known better than to try this.
Oh, I was wondering about the all-sky camera.
Yeah. Well, it's packed up to go down to Arizona. Okay, well, let's see. We would see if the Eagle was visible, we would have seen it. So right here, we would have seen it in this live view. Let me go just...
About the Omega.
Yeah, we can try the Omega, but I think it's sort of in the same relative...
Yeah, it is.
Same relative locations right here. So I'm not sure that we're going to be able to see it either. Let me just go look at the cloud status and see if we're just been very, very lucky up till now. And maybe I can look at a few other things. All right?
Okay.
So I'll be right back.
Try to keep them entertained.
I know. Sorry, guys. I'm a dismal failure.
Want to hear another song? Uh, I really like John Prine. He died here a couple of months ago from the coronavirus. Really sad. He's sort of a country singer, I guess you would say. He was, I don't know if you'd call him doper country or what. He first became known back in the 70s. Really cool guy. He did a song called Pretty Good. Uh, I used to sing this song on the chairlift when I was riding uphill going skiing. I got a friend in Fremont. He sells used cars, you know. Uh, and there it went right out of my head. Verse 2. I met a girl from Venus. Her insides were lined with gold. Well, she did what she did and said, "How was it, kid?" She was politely told, "Pretty good. Not bad. I can't complain. But actually, everything is just about the same." I'll not subject you to any more of it. I think you could hear a little bit of my hillbilly accent coming out. He was a really cool guy, though, John Prine. Highly recommend him if you never heard him. Yeah, what else? Doodah. I'm just sitting here waiting on Mark. I may go to bed here pretty quick. Uh, I've been trying to go to bed early. Hope I'm not boring you. Hey, Governor knows John Prine. Thank you, Tara. I guess that's a joke, but yeah. I heard Allah and Buddha were singing at the Savior's feast. Meanwhile, up in the sky, an Arabian rabbi fed Quaker oats to a priest. Pretty good. Not bad. You can't complain. 'Cause actually, all them gods are just about the same. Okay, hi Mark, welcome back.
Okay, I got to know what that was.
That was the song "Pretty Good" by John Prine.
Wow.
My faulty rendition of it, at any rate.
That was pretty good.
I
Okay,
assume you're punning too.
I like it. Well, okay, obviously things are not going our way. The clouds are entirely in the way. So what we need to do is I want to look. Might as well try and find Mars because Mars is up, and it's on the side where there's no clouds.
Let's see. It's 5 minutes till midnight at your place. Yeah, I noticed last night Mars is up by 11 o'clock now.
Yeah.
It is coming.
Yep.
You know, one thing I found interesting, we were talking recently about the oppositions of Jupiter and Saturn happening here in July.
Yeah.
And somebody mentioned when they're in conjunction. You know that they don't actually come into conjunction until December 21st.
Really?
Yep. Almost, you have to wait till almost the end of the year before Jupiter catches up with Saturn finally.
Wow.
I see Mars.
Well, we see what we think is Mars. Yeah, it's Mars. Yeah. So now what we have to do is we have to say, okay, we want it to be there. And we're going to probably, since we're on filter 1, should we try the narrow bands? See what we get with narrow bands?
Sure.
Yeah. Okay, well that's what we want. So now what we'll do is we'll head west a little bit and center it up. Okay. Yeah, I'm going to do this first. Okay, there we go. All right, so now what we have to do, because Mars is so bright, Obviously, what we need to do is we need to reduce the settings and drop them down to a reasonable set of values, which for Mars will be down to 50 ISO, which is this, and way less than 30 seconds. We're going to be down to just doing a small. Let's try 1.3 seconds to start with and see what we get. Let's see if we can see Mars. No, look at that. That's pretty interesting. We can see some type of detail on the planet. We got to actually, we need to actually, it's kind of low right now. As you saw, it was very low in the murk.
Yeah.
Yeah. And of course, we have the moon out too, which is causing an issue. But with this particular, maybe what I can do actually with this particular guy is to just, let's go over to filter 2. Okay. And drop us down another couple of stops. See, we got clouds too. You see that, how Mars is changing brightness? So we're shooting it through clouds as well. But we're going to do like a 0.4 second shot. So that should be fairly instant. Wow. Well, it's sort of interesting. What I'd like to do, though, is go into our planetarium program, which I'm going to do. In the planetarium program, I just got to get rid of the ground here for a minute. Planetarium program can show us what Mars looks like and what it should look like in the scope. All right, so this is what Mars should look like in the scope. Well, we're seeing that phase, that view. See that?
Yes.
We're seeing that for sure. I haven't seen Phobos because I'm not taking a long enough exposure. But let's see if Deimos is also visible. Yeah, see, Phobos and Deimos are there. Those two tiny moons. So we should be able to see Phobos and Deimos if we take a shot of it. So we should do that. All right, so let's go back here. And just for the record, let's go and take a photo that will encompass Phobos and Deimos. So let's bring us up here. Go up to 400. And let's go up to about, let's see if it'll catch it in 5 seconds. So 5 seconds at 400. Mars will be greatly overexposed, but maybe we can see Phobos and Deimos. Not yet. Got to go a little higher. All right. So let's go and do, we'll do 10 seconds. And let's go up to 1,000 and see if we can get it for 10 seconds at 1,000. And we do have clouds too, which are going to cloud away. Hey, Fantasy. Hey, welcome. Well, we're getting some stars anyway.
Is that Phobos on the left and Deimos on the right?
I'm not sure. I don't believe so. It looks like they're too far away. See?
Oh, yeah.
So we should see them very, very close to the planet. Like here and there, maybe.
Right.
All right, so let's try this again. Let's go back and say, all right.
Excuse me.
That's okay. 3,200 for 20 seconds. Long time. Mars will be hopelessly overexposed. but maybe we'll get something. Fantasy, I'd love to show you Jupiter and Saturn, but they're behind clouds right now, unfortunately. That whole end of the sky is. Okay. Let's see what we've got here. I don't think that's correct there.
Something to the upper left.
Yeah, I know, but I don't believe that's right. I think those are just two stars. Actually, it looks like we're still out of focus. How about that? And that could explain why we don't see it. Okay. This will be kind of hard. Okay, actually, what I can do is we'll do this. We're going to come down here. And we're going to get down to 50 ISO one more time. And we're going to bring this down till we can barely see Mars. Okay. And now we're going to a focus mode and try and focus on it. All right. And now I guess you have to bring it down. And I'll bring it down into the view. Here we go. There's Mars. And so what I'll do now is I will focus it right here. I'll take it out of focus. Then send it back into focus. You can see it bouncing around. It's got so much turbulence down there.
Yeah.
Okay.
If I'm going to wipe out much detail, you'd be able to see on the face of the planet.
Yeah. Let me see what this looks like. 1/5 of a second. Okay, let's see what we got here. Actually, not sure. That might... See, we're actually seeing all the microturbulence too. And
yes.
What we have to do is we have to... Oh, look, it's behind a cloud now. Ugh. They're caught up to us. Come on, go away, clouds. See, if I actually tell to do longer exposures, it'll bring it back out from behind the clouds. But you can see just how much the clouds are interfering.
Yeah.
And if we actually go up to this mode here, we're going to this, what I call like a 4K or night vision mode. You can see the clouds moving. Look at that. Let me actually move this.
Yep.
See that? So there's the clouds moving in front of Mars. Yeah. I mean, that's cool to see. I mean, that's just cool looking at the clouds moving too. It's just, but still, we're seeing it through the telescope. And it is sort of interesting. And I think we might get a little... We're right on the edge of the cloud, though, see? Yeah, right on the edge. This explains why we're not seeing much. Well, you know what? I know when to say I know when to say I've been beaten for the night. But I don't know. I think that I don't think we did too badly for the evening. Do you? We actually got to see a few things.
Oh yeah. Yeah.
Maybe I can do one more, just one more. Let me just try to bring this down. Let's stay 3200 for 25 seconds. Nope, not that. 25. Okay. 6400. Okay, 4000. That's even better. Now let me see if I can actually get a photo that can show us Phobos and Deimos. Yeah, James. Yeah, you did see darker patches. That's right. I saw some darker patches as well. We'll get there. It's in a very unfortunate position, right? Kind of low.
The best view I ever had of Mars, and in fact also the best view I ever had of Jupiter, were both through the viewfinders of cameras held up to the eyepiece of telescopes. And
Fascinating.
It was a strange thing, but something about the setup, it just, and the air, I guess the seeing was good that night. It just crisped up perfectly.
Wow.
Both times. And on Mars, I could see Syrtis Major, and I could see Sinus Sabaeus over to the side of Syrtis Major.
Okay.
And it looked beautiful. Like a picture out of a book.
Wow. So you have to wonder, like, why can't we do that? Why is that so hard to accomplish? All right, let's take
nowadays they, I guess, shoot video mode, don't they? And they just pick through all the exposures until they see good ones.
Yeah.
Yeah.
This looks pretty interesting.
Yeah.
That's a pretty good view of the red planet right there.
Yeah, as James said earlier.
Dark patches, see?
Yep. He could see, I think it's the south polar ice cap that's visible right now.
Mean up here?
Orientation, I'm not sure.
Yeah, I think that's the north right there.
Yeah.
I think the telescope shows it the same way as this does. So we should be seeing, actually, if we see the south polar ice cap, it's going to be, it's not even visible. It's right there. But can't really see it. Maybe I need to actually increase the amount of time just slightly, make it a little brighter. Kind of hard because we're actually look at, see, we're in clouds again.
Just faded up.
Well, actually, let's try something. Okay, that didn't work. What I was getting at was that sometimes we would see, sometimes we see things that, because the clouds actually help filter it, and it's rare, but it does happen. It's rare, but it does happen. So,
Mark, I'm sorry. I don't mean to be a lightweight, but I'm going to bail on you.
That's okay, because we're actually about to close up for the night because we're not getting very far with Mars tonight. It's going in and out of the clouds.
There it goes again.
And it's the last item up for bids here on The Price is Right for tonight. So we are actually going to close down for the night, guys. I want to thank you so much for being here. I promise next time we get together, the music will be back. We actually had a technical difficulty tonight, and we couldn't get the music to work right for some reason. But we'll be back in no time. So I want to thank you guys for coming out. Thank you so much for joining us. I'll leave you with just a couple of the night's wins for tonight. I want to thank Daryl for joining us tonight.
Oh, sure.
Yeah, you're fantastic, as always.
I'm a lightweight.
You're a lightweight. Okay, well, not really, but you're fantastic. You've done a lot for us. SkyTour LiveStream wouldn't be the same without you. Hey, if you're such a lightweight, I tried to leave Amanda a message and she never responded, so she's probably tied up with what she's doing.
I'm sure. I haven't heard from her in a day or two.
Yeah. Okay.
She's doing her Gish thing this week.
All right, guys. Thank you. We'll be back. This is the Lagoon Nebula. Okay. Remember that amazing O star right there that's powering this thing right here? This is really just a hot spot ow, it's hot. You know, that's really, really cool. So we'll be back next clear night, which could be as soon as tomorrow. I'm not sure. And just remember, if you go out, you just keep looking up, all right? Because that sky is there for all of us. And after the hurricane last night, the skies are actually rather clear. This is a beautiful view for a full moon night with clouds rolling through. Not a bad view here. Not a bad view at all. All right?
That's a pretty picture.
Yeah. Yeah. All right, Daryl, thank you so much for coming. And folks,
Oh, sure.
thank you for coming. And I will catch you next time. And maybe Daryl will be with us as well as Amanda. So we'll see you later, guys. You guys have a good night.
Take care. Good night, everybody.
Have a good night, guys.